All right, so no problem. All right, so let's start. A matrix is defined as rectangular array or arrangement in rows or columns. This is a precise definition of a matrix. So whatever, if we arrange numbers in rows and columns, for example, you see this is a row where some numbers are written A11, A12, A13 up to A1n, 2122 up to 2n. Okay. Similarly, we have columns as well. This is column 1, this is column 2, and so on. So if you count number of rows and number of columns, we write a matrix as m by n matrix. Okay. So m are the rows and n are the number of columns. They can be any number, of course. M can be 2, 3, 4, 5. N can also be 2, 3, 4, 5, right? So if we have 2 rows and 3 columns, we will write this is a matrix 2 by 3. So I'm writing with a mouse, so of course my writing will be very bad, but I hope you will understand. If you have any question, you can stop me and I will explain. So in general, what we can have m number of rows and n number of columns. So there is no comma anywhere. We will have some space between the numbers. You see, between A11 and A12, there is a space. We do not use any commas or anything inside the matrix. People use these big brackets as well as small brackets. Okay, you can write small brackets like this, parenthesis, and write the matrix here 1, 2, 3, 4. Right? This is also a notation for the matrix. So it's your choice. You want to use this straight bracket or this curved bracket. Okay. And now you see the example which I just wrote. It has 2 rows, 1 and 2, and 2 columns as well. So 2 rows and 2 columns. So this matrix is 2 by 2 matrix. Okay. So each element will be a real number. In general, it can have complex numbers, but we will start with real numbers. So each entry which I'm writing A11, A12, they are all real numbers. Okay. But when we write general matrices, we use this subscript, double subscript. You see, A11. What does it mean? First one is for the row, second one is for the column. So let's say if I pick this one, A23, it means this is the number in second row and third column. Second row and third column. You see, this is row number 2 and this is column number 3. So this is your second row and third column entry. Okay. So similarly, you can see any other one like M2. This is mth row. The last row is M and second column. Okay. And this is the last number, which is mth row in row M and last column, which is N. Now this, of course, M and N will have some numbers. They are not just mn. These are not letters. Okay. So m can be any number, n can be any integer, positive integer, because number of rows cannot be fractions. Number of rows cannot be 0. So they have to be 1, 2, 3, and so on. Positive integers, or what we say natural numbers. Okay. So each element of a matrix has 2 suffixes. We call them subscripts as well. Okay. And each suffix represents a row and a column. So the first one will give you a row and the second will give you a column which is it is in. Okay. For example, here A32 is the element in third row and second column. Third row and second column. Okay. All right. So the number of rows and columns that a matrix has is called the order of a matrix. What I just wrote 2 by 2 and 2 by 3. This is the order of a matrix. 2 by 3 indicates that it has 2 rows and 3 columns. So never write it as 6. We are not multiplying these two. Okay. 2 into 3 is equal to 6, but we do not say that 6 is the order. We don't say that 6 is the order. Order is always represented as 2 by 3 or 3 by 4 or 1 by 2. Okay. If you want to count how many elements are there in the matrix, of course, there are 6 elements. When you multiply 2 into 3, there will be 6 entries in your matrix, but they will be arranged in 2 rows and 3 columns. Okay, 1, 2, and 3 columns. So they will be arranged in 2 rows and 3 columns, but there will be total 6 entries. 6 is not the order, order is 2 by 3. Okay, so for example, this is the matrix. So what is the order? The order is 2 by 3. Why? Because there are 2 rows and there are 3 columns. Okay, so these are the rows on the left side. These are the rows and these are the columns. Okay, so we can write COL short for column. Okay, ROW row and COL for column. I'm writing this as a short. So the order of this matrix is 2 by 3. Okay, any questions? Are you getting me? Is it what I'm talking? Do you see the same thing on the screen as well? My voice
Yes,
and
Mr.
the okay, my voice and video is synchronized, right? All right. So there are certain types of matrices. Okay. Certain type of matrices, a matrix having only one row. Sometimes your matrix can have one row and several columns. Okay. Because row is just one, so we call it a row matrix. Okay. For example, these two things. There are one row and 3 columns. Here, one row and 4 columns. Okay, do not put commas, because usually when we put comma, if I put 1 2 comma 3, usually we refer this to a point in xyz space, right? In calculus 2 you must have studied, in xyz it will represent a point, right? So when we write matrices, we do not put commas. 1 2 3 means it's a matrix which has one row and 3 columns. This is a matrix which has one row and 4 columns. Okay, so any matrix whose order is 1 by n is a row matrix. Similarly, if we have one column and many rows, then it will be called a column matrix, because it has only one column. So its order will be n by 1 because it has many rows, right? And but column is just one. So this is a 4 by 1 column matrix. This is 2 by 1 column matrix. Sometimes we write the order at the bottom of the matrix. You see, 4 by 1, 2 by 1. Okay, so these are types of matrices. Similarly, we have a square matrix. You remember a square whose length and width is the same, right? If the length and width are equal, it's a square. So similarly, in a matrix, if we have same number of rows and columns, you see 3 rows, 3 columns, it means length and width of this triangular thing is equal. So we call it a square matrix. 2 rows, 2 columns, square matrix. 3 rows, 3 columns, square matrix. N rows, n columns, square matrix. You see? So a square matrix always have this order, n by n or m by m. Okay, rows and columns are the same. Any questions so far?
No, Mr.
All right. So it seems like there is only one student who is speaking up. All right. So whenever you have a question, you can stop me and I will explain more. I guess these are very simple things, so we should not be worried about that. Diagonal matrix. The next type is diagonal matrix. In a
مستر
diagonal, yes.
مستر سيف هذه المحاضرة
Add,
سيف
save this session.
yes yes
Yeah, I think I'm recording. Yeah, I pressed yes for the recording, so I think it is being recorded. So I will post it after that. Okay.
okay thank you
So basically, you want to leave, huh? All right. So a diagonal matrix is a square matrix whose diagonal elements are non-zero and off diagonal are zero. What do we mean by diagonal elements? Whenever you have a square matrix, these are the diagonal elements. These are the diagonal elements. So diagonal elements, and these are called off diagonal elements. Okay, non-diagonal or off diagonal elements. So you see, all elements which are not on the diagonal, they are zero, and elements on the diagonal are non-zero. We call this as a diagonal matrix. Okay, so any square matrix, so first thing is it has to be a square matrix. This is first condition. If a matrix is a square matrix and all diagonal elements are non-zero and off diagonal are zero, then it will be called a diagonal matrix. Even if one of the diagonal off diagonal element is not zero, for example, this number is not zero, it's 1, then I will not call it a diagonal matrix. Okay, so all elements which are not on the diagonal should be zero. Got it? Now another matrix whose all diagonal elements are equal. So it means it has to be a diagonal matrix first. A scalar matrix is a diagonal matrix whose diagonal elements are equal. Another condition, you see, now it is a diagonal matrix, but diagonal elements are also equal to each other. It can be 1, 1, 1, or 2, 2, 2, or 3, 3, 3, whatever. These are called scalar matrices. Okay. A very important matrix in the theory of matrices. One matrix is matrix and more than one matrices. We do not put S. We remove X and write CES for the matrices. Okay. So a very useful and very important matrix is called the identity matrix. Identity matrix is a scalar matrix. Now you remember what was the scalar matrix? Scalar matrix was a diagonal matrix whose diagonal entries are equal. Okay, but now we are putting another condition. We are saying that whose diagonal entries are unity. Unity means 1. Okay, so all diagonal entries are 1. So it is a diagonal matrix with diagonal entries equal to 1. So this is called, still messages are coming in the group. That's not important. Okay. All right. So this is the identity matrix. If you remember, what is an identity in real numbers? If I multiply a real number A, let's say, by some number, and my answer comes back to A, what do you think? What should be this number? If I multiply some real number with a number which gives me the same answer back, so what do you think? What should be this question mark? Anyone? What should be this question mark? No one is answering. Okay, I hope you know that. Maybe there's a problem. Here it should be equal to 1, right? If I multiply any real number by 1, I get my A back. 3 into 1 is 3. 10 into 1 is 10, right? So what we call this one? This one is called identity of multiplication. Okay, this one is called identity of multiplication. Why we call it identity? Because you get your number back by multiplying this number. So identity matrix has the same role in matrices. Identity matrix, when multiplied by any other matrix, gives you the same matrix back. Okay, so this is the reason we call it identity matrix. So we have to remember this. Similarly, another form is upper triangular matrix. Upper triangular matrix is when all the entries below a diagonal are zero and all entries above diagonal are non-zero. We call this upper triangular matrix. So if you look at this one, it becomes a triangle. You see, all elements which are non-zero make a triangle. Below the diagonal are all zero. So we call it upper triangular matrix. Okay. Similarly, if all the elements above a diagonal are zero and we have only non-zero elements below a diagonal, so you see there is a triangle, lower triangle. In this matrix, we have a triangle, but it is on the lower side, not on the upper side. So we call it lower triangular matrix. Okay. Similarly, if all the entries okay, so here all the entries in this matrix are real. You see, square root of 3 is a real number, 5 minus 6, 2.5, square root of 7. All elements are real numbers. So we call it a real matrix. If at least one number inside your elements is complex, complex is when you have iota in it, right? You remember a complex number, right? From calculus 2, a complex number has this form. You have a real number plus iota, another real number, right? What is iota? Iota is square root of minus 1. Okay, so if at least one entry is complex, we call it a complex matrix. Okay, so even if at least one element, not all elements have to be complex. You see, 1, 0, and 2, they are real numbers, right? But other three elements are complex. Even if just this element is complex, we will still call it a complex matrix. Okay. Now, there are some matrix operations. You know, when we study anything, when you studied real numbers for the first time, you studied the operations of the real numbers, that how can we add them when two real numbers are equal, how we can multiply real numbers, right? So similarly here in matrices, we will study some operations which are necessary in the theory of matrices. So first of all, what is the equality of matrices? When two matrices will be equal? Two matrices A and B are said to be equal if and only if they have the same order. This is the first question, first property. They have to have the same order. And the second condition is each element is equal to the corresponding element in B. Corresponding element in B means the first one should be equal to the first one, second should be equal to second, okay, third should be equal to third. So it's not that if all elements, let's say there are 6 elements, 1, 2, 3, 4, 5, 6, and other matrix also have the same elements but in different arrangement, we will not call them equal matrices. Okay, so the first one, for example, the first entry here, this A11 should be equal to this first entry B1. Similarly, this A12 should be equal to this B1. A32 should be equal to this B32. Then we will call them equal matrices. All right. Now, if two matrices are given, how can we add them? We can add two matrices by adding the corresponding elements. You see, A11 will be added to B11. A22 will be added to B12. A13 will be added to B13. A22 will be added to B22. Okay. So all corresponding elements you have to add. So A11 plus B11 should be your first entry. A12 plus B12 should be your second entry. A21 plus B21 should be your third entry, and so on. And the last one will be A32, B32, and at the same location. You see, this was the third row, second column, third row, second column. So this should come in third row, second column. So you cannot change the order when you add two matrices. Similarly, you can subtract them as well. So if you subtract them, A11 minus B11, it will become A minus B. Okay. So you are sending messages, I think, for one another in the group, not for me. Okay. So similarly, you can subtract the first one from the first one, the last one from the last one, this A22, B22. Okay, so you have to be careful about the position of these numbers. Okay, so you have to add or subtract the corresponding elements from the same location and put it in the same location as well in your answer. For example, this last one should come in the last place. Any questions, guys? Are you guys here? Or turn on the Zoom and left. So we have 22 participants. Anyone who can say yes or no, or if you have any questions. Okay, let me see who is here. Aham is here. Aham, can you speak?
Yes, doctor.
Understand everything? Any questions?
No, I don't have any question.
All right, so I hope this is the same situation with everyone. Let me see another name. Some people have names of their phones. Ahood is here. Ahood, can you say something? Yes or no? Mariam,
Yes, Mr.
understand everything?
No.
No? Any questions? Let me know. If you have any questions, any one of you can ask. Okay, so I think I should start. You are answering in the chat, but I don't listen. Maybe you have to unmute your mic first and then talk. Should I unmute everyone or what? I did not mute anyone, so I think you can talk in your Zoom. Okay, so you are sending messages. You see, you guys are smart. All right. So all right. So let's start. Let's continue from where I stopped. All right. So now after addition, so there are some example coming up. Okay, examples are coming up after finishing this theory. I will do some examples here. So I think if you have any doubts in your mind, that will be clear in the examples. So matrices of same order can be subtracted and added. Okay, so this is one point to remember. Matrix addition is commutative. What we mean by commutative means if you add A in B or add B in A, we will get the same result because we are adding real numbers, right? Real numbers are commutative. 2 plus 3 is the same as 3 plus 2. The third thing is